All right, so I apologize for this video being a little bit late getting up. I had some difficulty in class recording it, so I just decided to record it after school. So we are going to wrap up the last little bit of indicator 7. So this is indicator 7.4 or day 4. And we are going to be graphing absolute value functions, okay, or absolute values. So as a review, an absolute value tells you the distance that something is from 0. So if you look at the absolute value of -3, it equals 3. And if you look at the absolute value of +3, it also equals 3. And what that means is if you have a number line and you have 0, and you have -3 here, and you have +3 here, all the absolute value tells you is that it's 3 spots from 0. And it doesn't matter if it's in a positive or negative direction. It just tells you the number of steps from 0. So absolute values always equal a positive number because it's just the number of steps it takes to get to 0. So the absolute value of -3 is 3. The absolute value of +3 is also 3 because both are 3 jumps or 3 steps or 3 spots from 0. That's just a little bit of review because we will need that information when we are graphing these absolute values. An absolute value graphs in the shape of a V, and so if you get your 5 points and they do not make the shape of a V, then you probably should go back and look at your math somewhere and see if you haven't made some sort of error. So let's look at example number 1, and this is going to be, we're going to do 5 examples. And example number 1 is kind of your basic absolute value equation. So it's y equals the absolute value of x. Now this is called a function. Basically a function is just an equation that if you run a number through it, it's going to give you its coordinating value. So we want an x and a y to graph it on a coordinate plane. And so if we pick some x's and we plug them into the function, we're going to spit out the y's that go with those x's. I kind of equate it to like a Hershey Kiss factory. So at the beginning of the factory, you've got all the raw ingredients, the sugar and the cocoa and the milk and the butter and whatever goes into Hershey Kisses. It runs through the machine or through the function, and then it spits out little Hershey Kisses, right? So you take the ingredients, you run it through the machine, and then you get your end result or your answer. So for these absolute value functions, we are going to put in x's. Those are going to be our ingredients. And when we put in an x, we're going to spit out the result when we run it through the function. So what does this look at? Well, first thing you always do, step 1, is you create an XY table. XY, okay? Every single time you need an XY table. And then you need to thoughtfully pick 5 x's, okay? 1, 2, 3, 4, 5. So we're going to pick 1, 2, 3, 4, 5. We're going to pick 5 different x's, okay? And you don't have to number those every time. I'm just doing that this once. You're always going to pick your center one first, okay? This is going to be your vertex or the center or the point of your V when you graph this. And so what you want to do is you always want to pick whatever value x needs to be in order to make inside here equal 0. So inside the absolute value, we need it to equal 0. And if we want to plug something in for x to make it 0, well, here it's kind of easy because the only thing in there is an x. So if we choose 0 as our x value, then that means when we plug 0 in, it's going to equal 0 inside that absolute value. So that's our center number that we want to pick. Then we want to pick 2 numbers before 0 and 2 numbers after 0. And we're just going to pick the next 2 numbers before and the 2 numbers after. So the next 2 numbers after 0 are just 1 and 2. And the 2 numbers before 0 are -1 and -2. So we very smartly or wisely chosen our 5 x's that we are going to run through our function and get the coordinating y's. Well, so we have to work this function right here. We have to work it 5 different times because we have to work it with a -2 in the x place, then we have to work it with a -1, a 0, a 1, and a 2. So let's work it 5 different times. So if we have y equals the absolute value, and in place of the x, I'm going to put a -2 because I'm running it through my first time with a -2 in for x. Well, this is where knowing that absolute values always come out positive or always equal positive, because the absolute value of -2 is 2. So when x is -2, y equals 2. So I'm going to fill in my t-chart as I work each one of these functions using different x values. So now I'm going to do it with -1 in my x spot. Well, the absolute value of -1 is +1. So I fill in my t-chart. Now I'm going to work it with a 0. The absolute value of 0 is 0, so I can plug that in. So when x is 0, y is 0. Now, when x is +1, the absolute value of +1 is 1. And then I'm going to do my last one, which is I'm going to work it with a 2 in that x spot, and the absolute value of +2 is +2. Now I have filled out my t-chart. So I have very wisely chosen my x's, okay, considering my hub x first. And then if you'll notice, if you choose your x's correctly, your y's, okay, this is your vertex, right? The V, the part of your V, the point of your V. When you do this correctly, these y's right here should mirror each other, which they do, 1 and 1. And then these y's right here should mirror each other, which they do. They're 2 and 2. They should match. So if you do your t-chart right, and you do all your math right, and you pick your x's right, your y's should have your center y, and then your next 2 out should mirror each other, and then your next 2 out from that should mirror each other, and they do. So now we just have to graph this. So let's give ourselves a coordinate plane here. And now we have 5 points that we're going to graph. So if you look at this one right here, right, this is the point -2, 2. So I'm going to graph the point -2, 2, which is right here. Now the next one, on this number 2 row, is the point -1, 1. So I'm going to graph the point -1, 1. Then I'm going to graph my red, right, my vertex here. This is my hub or my vertex. I'm going to graph that at 0, 0. And then my next point is 1, 1. So 1, 1, and then 2, 2. Now when you're done, your points should create the shape of a V, and they do here. So that means we just have to draw our V-shaped graph here. And that is the example number 1, y equals the absolute value of x. This is the graph that represents this function. Okay, so for every time, step 1, you draw your t-chart. Step 2, you decide your middle point for x. Then you pick x's on either side of that, 2 and 2. And then you have to run your x's through the function one at a time, get the y that goes with each x, fill in your t-chart, and then graph each point. Okay, so let's do another example. All right, so we have y equals x plus 1. Okay, here's our absolute value. Step 1, draw our t-chart. Okay, step 2 is I'm going to pick 5 points, and remember the first one I'm going to pick is my middle one. Okay, so for my middle point, I want to pick whatever value I need to plug in right here for x in order to make x plus 1 0. Well, the x value I need here is -1, because if I plug -1 in for x, -1 plus 1 is 0. So that's my center number. And then remember, I'm going to pick 2 more and 2 less. So -1, 0, 1, -1, -2, -3. So I picked 2 numbers before -1 and the 2 numbers right after -1. Now I need to take my function and I need to plug -3 in where there's an x. So I've got y equals -3 plus 1. Well, -3 plus 1 is -2, And then the absolute value of negative 2 is positive 2. So I'm going to fill in my t-chart when x is negative 3, y is 2. Now I'm going to do the same thing, and I'm going to plug negative 2 in to my function. Well, negative 2 plus 1 is negative 1, and the absolute value of negative 1 is positive 1. And then I'm going to plug negative 1 in. Well, I know that's going to equal 0 because I did it on purpose. I picked negative 1 plus 1 equals 0. So I know that's 0. And then I'm going to run it again, and I'm going to put a 0 in for x. So 0 plus 1. And you notice every time I've got the absolute value symbol plus 1, it's x plus 1. So each time the only thing changing is my x value here in this spot. Then I've got plus 1 on each one. So 0 plus 1 is 1, and the absolute value of positive 1 is 1. And then I've got y equals the absolute value of 1 plus 1 equals the absolute value of 2, and the absolute value of 2 is 2. Now again, if I did it right, this is my vertex. These two should mirror each other, and they do. And these two should mirror each other, and they do. So that means that we are ready to graph. So let's see, draw myself a graph here. And whoops. There we go. Sorry about that. All right, so now we're going to graph each one of these points. So we have the point negative 3, 2. So negative 3 is the x, so I go backwards 1, 2, 3, and then I go up 2, which is right here. And then I've got negative 2, negative 1, whoops, yeah, negative 2, 1. And then my vertex point, which is right here, is negative 1, 0. And then I've got my next point is 0, 1. And my next point is 1, 2. And again, you can see that my points do make a perfect V. And so there is the graph for the function y equals the absolute value of x plus 1. Now you'll notice I had a change in here, right? I had a change in my x. So if you'll notice my graph, this is my x-axis, you'll notice that my graph on my x-axis, it shifted by 1, right? So instead of like this one, where the hub was right at 0, 0, right? This one down here, the second example, this was example number 2, the second example, my vertex shifted over 1 because this change, this shift right here in the x shifted my whole graph on the x-axis over by 1. All right, let's look at another example here. So this is example number 3, and we have y equals the absolute value minus 2. Y equals the absolute value of x minus 2. Now, you'll notice that there is a shift here, right? This negative 2 is a shift, but it's not a shift inside with my x. It's a shift outside, so it's going to actually affect my y. But we start out the exact same way, which is our x and our y chart, okay, our t-table. So we need to be smart. We need to pick the right x's, and we always want to pick our middle x first. And what do we need to plug in for x to keep inside the absolute value? 0. Well, here, since the x is the only thing in there, it is 0. And then 2 spots before 0 would be negative 1, negative 2. 2 spots after 0 would be 1, 2. Okay? So there's my 5 x's. And now I'm going to run my equation or my function 5 different times, and each time I'm going to plug a different value in for the x. So I'm going to have y equals the absolute value, and now in this line I'm going to plug a negative 2 where there was an x, and then minus 2. That minus 2 that hangs out at the end, that stays with you. All you're doing is plugging in an x value for an x value. So here you've got the absolute value of negative 2 is 2, and then that minus 2 is just still part of the equation, and 2 minus 2 is 0. So I can plug a 0 in there. Now I've got the absolute value of -1 and then -2, because remember this -2 right here, it's just part of the equation, so it just keeps going at every time it gets put in your function here. So I plugged a -1 in for x. The absolute value of -1 is 1, and then -2, and 1 minus 2 is -1, so I can plug a -1 in here. And now I'm going to do absolute value of 0 minus 2. Well, the absolute value of 0 is just 0, and then I subtract that 2, so I get -2. Now, thinking through here, what should I get for my next y value? Well, remember that, right, this is my vertex, and remember that these two should mirror each other, and then remember that these two should mirror each other. So what should I get for my next y? I should get -1, because my -1 from above my vertex should mirror my -1 above below my vertex. And then the next one down should be a 0, because it should mirror the 0 that's 2 above. 2 below and 2 above should mirror each other. But let's test it. So let's plug in -1. Well, -1, the absolute value of -1 is 1. So 1 minus 2 is -1. That checks out right there. And then y equals, if I plug 0 in, -2. 0 minus 2 equals -2. Oops. What did I do? Sorry, I plugged the wrong thing in. That was my fault. I wasn't plugging a 0 in. I was supposed to be plugging a 2 in. That was my fault. Right here, I'm supposed to be plugging 2 in for x. So a 2 in for x, 2 minus 2 equals 0. Sorry, I was looking at the answer to be 0, and I was plugging 0 in. All right, so now I've got my 5 points, right? I'm ready to graph. So let's give ourselves a graph here. All right, so we're going to plot the point -2, 0. That's our first point right here to plot. So -2, 0 is right there. And then -1, 1. -1, -1 is there. And then our vertex point is 0, -2. 0, -2. And then our next point is 1, -1. And lastly, 2, 0. And again, you can see that these make a perfect V, with your vertex being at the point of your V. So if you pick the right first point, that center point, that x value that's the center, it should always work out that that is the point of your V. Okay? All right, let's look at example number 4. All right, so this has a shift inside with the x, and it has a shift on the outside with a y. So we'll see here in a second what that does to our graph. But first things first always is, let's get our xy table. And first things first, always pick your center point. Well, I look in here and I say, what do I need to make that x? I ignore the +3 right now. What do I need to make that x in order for inside the absolute value to equal 0? Well, if I make my x a 2, then that would be 2 minus 2 is 0. So that checks out. That's a good center point. So there's my center x. Now I need to pick 2 points before and 2 points after. So an x before 2 would be 1 and 0, and after 2 would be 3 and 4. All right, so I picked 2 numbers before and 2 numbers after. All right, so let's run this through. So these take up a little bit more room, so I will scroll up here just a little bit. All right, so first thing I'm going to do is I'm going to take my very first x value right here, which is a 0, and I'm going to plug it into that whole long function. So y equals absolute value of x, which is 0, minus 2 plus 3. You'll notice I rewrote the function just as it is. Y equals absolute value x minus 2 plus 3, but in place of the x, I put a 0. Now, you have to think of PEMDAS, right? PEMDAS says you do parentheses which in this case absolute value signs are the same as parentheses. We don't have any exponents. And then we don't have any exponents. Then we do multiplication, division, addition, subtraction. Well, we don't have any exponents or multiplication and division. So the first thing we're going to do is our absolute value or our parentheses. So inside the absolute value, we have 0 minus 2, which is negative 2, plus 3. And we're going to keep simplifying that absolute value because we have to get rid of those absolute value signs before we can add the 3. So the absolute value of negative 2 is positive 2, right? Because all absolute values come out positive. And then plus 3. And then 2 plus 3 equals 5. So now I can plug a 5 in my t-chart when x is, right here, when x is 0, my y equals 5. All right, now I'm going to do that again, only this time in the x spot, I'm going to put a 1. So I've got 1 minus 2 plus 3. X minus 2 plus 3. My x here is a 1. So I've got 1 minus 2 is negative 1 plus 3. And then I have to keep going with my absolute value. The absolute value of negative 1, all the absolute values come out positive, so 1 plus 3. So that equals 4. So my t-chart, I can keep filling that out. Now I'm going to do it again, only this time I'm going to plug in my red 2. So I've got y equals 2 minus 2 plus 3. Well, I know 2 minus 2 is 0. And the absolute value of 0 is 0. So that equals 3. So I can plug that point in. Now, I really don't have to do any more math, right? I know, based on my mirroring concept that I've already established, that this is going to be a 4 and this is going to be a 5. And I get that because around my, remember this is your vertex, around my vertex, these two should mirror each other and these two should mirror each other. Now, if I want to check my math just to make sure, I can run this positive 3. I'm just going to do it verbally. I'm going to run that positive 3 in my function. 3 minus 2 is 1. The absolute value of 1 is 1. 1 plus 3 is 4. So that one checks out. If I check out my 4 and I run my 4 through there, 4 minus 2 is 2. 2 plus 3 is 5. So that one checks out. So now I'm ready to graph. So really, you only have to do the math for the first 3. And then if you remember your mirroring properties, you can fill out the rest of your t-chart with your mirroring properties. All right, so let's draw our graph here. And let's see. Obviously, your graphs in your notes are not going to be perfect because you don't have lines, and that's okay. Mine aren't perfect either. All right, so let's graph these points. So the first point I'm going to graph, is the point 0, 5. So 0, 5 is right there. And then I'm going to graph the point 1, 4. So 1, 4 is right there. And now I'm going to graph my vertex of 2, 3. So 2, 3 is right there. And then I'm going to graph the point 3, 4. So 3, 4. And then lastly, the point 4, 5. So over 4 up 5 is right there. And again, should make a perfect V. If it doesn't, you've probably got some wonky math somewhere. So if you end up with some rogue point out here or down here, right, you've probably done some math wrong and you need to check your math down there at the bottom. All right, so again, right, it makes a V. If you look at your shift, right, you had a shift here, so it should have shifted it over the X, and that causes a shift on the X that way. And then here, that causes a shift upwards 3, and our graph does shift over 2 and up 3, and our vertex is over 2 and up 3. So that's where those shifts come in. All right, one more example, and then I will explain your homework to you. So example number 5 is y equals, there we go, y equals negative x plus 2 minus 3. All right. Actually, hang on before there we go. Minus 4. There we go. All right. So first things first, draw your T-chart. It's always how you start. Next, pick your center hub, which, looking here, right, what do I need to make X to make just inside those brackets 0? Don't worry about anything on the outside for your hub picking. Just look inside the absolute value. If I make X a negative 2, negative 2 plus 2 is 0. So there's my center one. Two numbers smaller than negative 2 are negative 3 and negative 4. Two numbers greater than negative 2 are negative 1 and 0. Excuse me. All right, so again, we have to run this through, and I'm going to do it across the bottom again. I have to run this through at least 3 times. So I'm going to take my whole equation, which is y equals negative, and then absolute value, and in this case, I'm going to put a negative 4 in, so negative 4 plus 2 minus 4. Okay, that's my whole equation, including my little negative hanging out front and my minus 4 at the back. All I did was plugged a negative 4 in for the x. So PEMDAS says, again, let's look at this, right, parentheses exponents. So I'm going to work inside my absolute value first, then multiplication and division. So my multiplication and division is going to be that negative out front, and then addition and subtraction is going to be my negative 4 at the end. So let's work on just inside those parentheses for right now. So leave that negative alone. Negative 4 plus 2 is negative 2 minus 4. Now I have to deal with that absolute value. I'm not messing with that negative sign yet, right? That's multiplication and division, and I'm not there yet. I got to evaluate the absolute value of negative 2, which is positive 2. Now that negative can attach, and then drop down the minus 4. And now lastly, negative 2 minus 4 is negative 6. So I can plug negative 6 in to my equation. Now I'm going to do the same thing. I'm going to do y equals negative absolute value, and I'm going to plug a negative 3 in. Remember to drop that negative. I'm not messing with that yet. Negative 3 plus 2 is negative 1. I'm going to get rid of my absolute value signs. That negative is going to drop down. It's still the multiplication step. I'm not there yet. The absolute value of negative 1 is 1 minus 4. Now I can take that negative 1, or that negative times the 1, which gives me negative 1. Negative 1 minus 4 is negative 5. And then last, I'm going to do it again. I'm going to jump up a little bit to give myself some room. I got y equals negative absolute value. Negative 2 plus 2 minus 4. Well, negative 0 minus 4. Negative 0 minus 4 equals negative 4. Now, I can use the mirror property here to fill in that this is negative 5 and this is negative 6. And if I want to test it, take negative 1 and plug it in. Negative 1 plus 2 is 1. Absolute value of 1 is 1. Apply the negative. Negative 1 minus 4 is minus 5. Same thing, if I plug a 0 in, I get 0 plus 2 is 2. Apply the negative. Negative 2 minus 4 is negative 6. So my other two, these two check out just by doing a little mental math real quick just to make sure. And then last, I'm going to graph. All right, so we have the point negative 4, negative 6, which is right here. Then we have the point negative 3, negative 5. And then our vertex point, which is right here, is negative 2, negative 4. So if I do it right, this should be where my graph turns around and starts heading the other direction. So negative 1, negative 5, negative 1, negative 5 is right. Oops. Well, there we go. Negative 1, negative 5 is right there, and then 0, negative 6 is right here. And again, it does make a V, but look what it does. It's an upside down V. That should have been right there. The reason it's upside down is because this negative sign right out here, the one that's out in the very front that you kind of have to wait to the end to apply, that causes your absolute value graph to flip, and it actually is an upside down V. So if you have a negative hanging out front, your V should be upside down, okay? And if you get some rogue point like up here or up here, it probably means you didn't follow PEMDAS and you applied a negative before you got it out of the absolute value, or you forgot your negative, okay? So let me erase those rogue points. All right, so for your homework, on Tuesday, if you're in class on Tuesday, I handed out a paper copy. You only need to do numbers 1 through 6. And then if you're going to be in class tomorrow, you'll do the other 4 in class. Or if you're at home, you can get on Kami, pull up the assignment that is 7.4 graphing absolute values, do all 10 on Kami. The first 6 are the homework assignment. The back 4 are going to go in as your quiz grade for absolute values. So you can just do all 10 and then submit it through Kami. If you have any questions, shoot me an email, and I'm always happy to help via email or through a video chat after school. Let me know if you need anything.